Hi everyone. In this video we're going to review the parent graphs for sine and cosine, look at some of their characteristics, and then I'm going to show you how to transform the graph of sine and cosine using transformations. Okay, so remember that trig functions are periodic functions, which means that they repeat. Okay, periodic functions repeat. And so if you can identify that one period, then that's the part of the graph that just repeats over and over and over. Okay. For sine and cosine, the period is 2 pi, which remember is a full revolution on your unit circle. So sine and cosine functions repeat their values every 2 pi, which I hope that makes sense, because if you relate it back to the unit circle, if your terminal side, rotates 1 revolution from 0 to 2 pi, then remember your sine and cosine values for each angle come from the ordered pairs, where cosine is the x-coordinate and sine is the y-coordinate. So if your terminal side, let's say, did a 2nd revolution, then those same values are going to repeat. Okay, so the period for sine and cosine is 2 pi, which again is a full revolution of your unit circle. Okay, and so again, those values are going to repeat. And so when we graph those values, you're going to get a graph that repeats, just like your unit circle. Okay, so what does that mean? Well, that means if you're finding sine of t, that would equal sine of t plus 2 pi. And here, t is the angle. So remember, t plus 2 pi is just essentially a coterminal angle with t, right? T and t plus 2 pi are coterminal angles. So again, they would have the same value for sine. And same thing for cosine. Cosine of t would equal cosine of t plus 2 pi. Now, for any integer n, sometimes we will add 2 pi n to this, where n is an integer. So that way, if n is 1, we're adding 2 pi. If n is 2, we're adding 4 pi. If n is 3, we're adding 6 pi. Okay, so 2 pi n just represents your terminal side rotating around that unit circle repeatedly. Okay. Sometimes you'll see it written as 2 pi n, and then sometimes you'll see it written as 2n pi. I'm kind of used to it like this, but it's the same thing because you're multiplying. Okay, now let's look at the graphs of the parent functions. We're going to start with cosine. So this is a graph of cosine of x, or cosine of t. We're just using t for the variable here. So the one period of cosine, remember, is from 0 to 2 pi. And so if we just repeat that period or that part of the graph over and over and over, then you get a wave. Okay? All right, so let's look at some of the characteristics. Domain. Well, remember that we have arrows at the end, so this graph is going to keep going in both directions. So the domain is negative infinity to infinity. Range, though, remember, stands for your y value. So, if you read the graph from bottom to top, your y values are always between negative 1 and 1, inclusive, meaning we're including negative 1 and 1. All right, we already talked about the period. The period is 2 pi, and again, that's the part of the graph that repeats. All right, even and odd. So remember, even and odd functions has to do with the symmetry of the graph. This graph is actually symmetric with respect to the y-axis. Let me show you that if we flip the graph over the y-axis, I'm going to flip it left to right, you get the same graph. So that's pretty cool. Okay, so that makes this an even function. Okay, your y-intercept, which is pretty easy because that's just 1 point, your y-intercept is 1. Your x-intercepts, though, your x-intercepts are actually infinite, because remember this graph is going to keep going. And so the graph is going to continue to cross the x-axis as it goes up and down, up and down, up and down. So the best we can do for our x-intercepts is try to see a pattern. Now, these values would be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. That does not look like a 2. So hopefully you're seeing a pattern. It's like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So we can say that the x-intercepts are n pi over 2, where n is an odd integer. Where n is an odd integer. So that way, if n is positive 1, then it's positive pi over 2. If n is negative 1, it's negative pi over 2. So again, it's just a way to represent that pattern. Another thing you could do is you can always identify maybe like that first positive. So we could also say our x-intercepts are pi over 2 plus or minus. And then notice that we're adding 1 pi each time. Or the difference between the two would be 1 pi, because 3 pi over 2 minus pi over 2 would be 2 pi over 2, which is pi. So we could say plus or minus n pi, where n is an integer. I mean, you'll see it both ways. But basically they mean the same thing. All right. Let's move on to the graph of sine. So this is our parent graph for sine. And again, sine and cosine look very similar. Their graphs are both waves. But the one period for sine, which again is 0 to 2 pi, looks like this. And notice that if we repeat that part of the graph over and over and over, then we get a wave. And if we look at some of the individual characteristics, again, we have arrows at the end because this is going to keep going in both directions. So domain is negative infinity to infinity. Your y values are still negative 1 to 1, just like cosine. The period is 2 pi, just like cosine, but from there, the characteristics start changing. Okay, let's talk about even and odd. So again, even and odd has to do with the symmetry of the graph. So the symmetry of this graph is rotational symmetry. If I take this graph and I rotate it 180 degrees around the origin, voila, we get the same graph. Remember, this is what it means to be an odd function. Odd functions, or the graphs of odd functions, have rotational symmetry. So that was pretty neat. Okay, now let's start with y-intercept. That's easy. Sine goes through the origin, so your y-intercept is 0. X-intercepts, again, they are infinite, so let's see if we can figure out a pattern. So it's kind of looking like 0, 1 pi, 2 pi, 3 pi, 4 pi. So how about if we just say n pi, where n is an integer. That would cover the positives and the negatives. Another way you could say that is we could start with 0, our y-intercept, plus or minus n pi, where n is an integer, because again, it repeats every 1 pi. Just a different way to do it. functions. Both graphs look like waves. They have the same domain and range and the same period, but your x and y intercepts are different and the even and odd is different. So honestly, an easy way to tell them apart is to look at your y-intercept and your x-intercepts, and then the symmetry. All right, so how do we transform these? So we are still using the same transformations that we learned with our other parent functions, like A is a vertical stretch of compression. If A is negative, the graph is flipped over the x-axis. B is a horizontal stretch or compression. If B is negative, the graph is flipped over the y-axis. H is your shift to the left or right, and K is your shift up or down. So the transformations are the same, but because of the nature of these functions, we use a little bit different terminology. Okay, so we often refer to A as the amplitude. So to find the amplitude, it's always the absolute value of A. All right, and because these are periodic functions, it's helpful to find the period. So the period for the parent function is 2 pi. Now what's going to change that is B, because B is a horizontal stretch or compression. So, that's going to affect your x-axis. Okay, so your new period is 2 pi over B, or divided by B. Okay, your phase shift. The phase shift is your horizontal shift to the left or right. Again, we're just giving it a new name. So remember how your left-right shift is always opposite what it seems? So it's the opposite of h, or negative h. But then remember how we always had to factor out b? Well, in order to factor it out, we're going to divide by b. So your phase shift is always negative h divided by b. So you always want to start these graphs by finding these 3 things: amplitude, period, and phase shift. And then you're ready to start sketching your graph. Now, I know this can seem confusing, but when you see it in action, it's not as bad as it sounds. But we're going to, your starting point is always going to be your phase shift. To find the stopping point, you're going to add period to your phase shift. And then you're going to essentially set up your x-axis by adding 5 points. I like to call them tick marks on your x-axis, and then include your start and stop points. Then you're going to find the midpoint between the start and stop points and add that to your graph. I actually am going to let you skip these 2 because otherwise it's going to be very time consuming to sketch these graphs. Then you're going to set the appropriate scale for your y-axis, which is basically your amplitude, and then you're ready to just sketch sine or cosine. All right, let me show you how this looks in action. All right, so here's our function, y equals 2 times cosine of 1/2 x minus pi over 2. So this is your a, your b, and your h. Okay, so step 1, we're going to find the amplitude, which is going to be the absolute value of a. The absolute value of 2 is equal to 2. All right, step 2, find the period. Okay, the period is going to be 2 pi divided by b. So your b is 1/2. Okay, so this is the same as 2 pi over 1 times the reciprocal of 1/2, which is 2 over 1. Multiply straight across and you get 4 pi. All right, number 3, we're going to find the phase shift. Okay, so that's the opposite of h. So here h is negative pi over 2, so we're going to make that positive pi over 2. Okay, divided by b. So that's going to equal pi over 2 times 2 over 1, multiplied by the reciprocal. Your 2's are going to cross reduce, multiply straight across, and you get 1 pi. Okay, you're ready to start setting up your graph. Always start with your x-axis, and you always need 5 points or tick marks. And just try to evenly space them out. Okay, first tick mark is always your phase shift. So that's 1 pi. Your last tick mark is your phase shift plus your period. So this one's easy. 1 pi plus 4 pi is 5 pi. That's your starting and stopping points. Okay, to find the middle, you're going to find midpoint. So to find midpoint, you add your endpoints. So pi plus 5 pi is 6 pi, and then you divide it by 2, so that's going to be 3 pi. Now I'm just requiring you to find that one midpoint. Usually after you find that one midpoint, you can kind of see what the scale is, you know, and this one is easy to fill in the rest because this would be 2 pi and 4 pi. But I usually just require that you label the 3 tick marks. The starting point, the stopping point, and the one midpoint. Okay, now we're ready to set our y-axis. So our y-axis is going to be out here, and this is where we're finally going to use that amplitude. So amplitude is going to, instead of the range being -1 to 1, like the parent function, it's now going to be -2 to 2. Okay, so we're just going to label -2 to +2, and then we're ready to sketch our graph. So this is when you want to pay attention to which function you're sketching. Here we're sketching cosine. So at first tick mark, remember cosine starts up, and then it goes down, down, up, up. And your final graph, you know, should look similar to that one period of cosine, because I'm only requiring you to sketch one period. If we, you know, repeated that part of the graph, then it would look more like a wave. Okay? All right, let's look at an example for sine. So this time our function is y equals 4 times sine of 1/4 x plus pi over 8. So again, this is our ABH. So the amplitude is going to be absolute value of 4, which equals 4. The period is going to be 2 pi, I'll make that a fraction, divided by 1/4, which is going to become 2 pi over 1 times 4 over 1, which is going to equal 8 pi. And then our phase shift is going to be the opposite of h. So because h is positive, we're going to make it negative. So negative pi over 8 divided by b, which is 1/4. And then we'll multiply by the reciprocal. The 4 and the 8 are going to cross reduce. 1 and 2. Multiply straight across, and we're going to get negative pi over 2. Okay, start with your x-axis. You need 5 tick marks or points. You label the first one with your phase shift. You label the last one with your phase shift plus your period. Now, because we're adding, we do need a common denominator, so we'll multiply by 2 top and bottom, and 8 pi over 1 will become 16 pi over 2. Add your numerator, and we get 15 pi over 2. Okay, to find our one midpoint, we're going to add our endpoints. Okay, so that's negative pi over 2 plus 15 pi over 2, which is going to be 14 pi over 2, which actually simplifies to 7 pi, but then we have to divide it by 2 to find the midpoint, so it becomes 7 pi over 2. Okay, now, where do we put the y-axis? Well, if I were to find, and really, honestly, if you kind of, you know, get faster with this, but if I wanted to label this tick mark, I would just go negative pi over 2 plus 7 pi over 2 is 6 pi over 2, which equals 3 pi, but then divide that by 2. So this is 3 pi over 2. If I were to find, let's say, the midpoint between those 2 points, I would get 2 pi over 2, which is pi, divided by 2 is pi over 2. So, make a long story short, your y-axis is going to be right smack dab here in the middle between negative pi over 2 and pi over 2. But as long as you get it, about where it's supposed to be, I'm usually happy with that. But that is why I always say label your x-axis first and then put in your y-axis, so you'll kind of know where it's going to fall. Okay, now this is where we're going to use our amplitude. So we need to label our y-axis from -4 to +4. And then we're ready to sketch our graph. We're sketching sine. So again, you want to start at your first tick mark. Now sine starts at 0 on the x-axis, or excuse me, the y coordinate of sine is 0. Anyway, you start sine on the x-axis with the first point, and then you go to the next tick mark. It's going to go up to 4, back to 0, down to -4, and then back to 0. And you end up, again, with that one period of sine. And again, I'm only asking you to sketch one period, but if you were to repeat this one period, then you would see the wave for the graph of sine. All right, so you guys will practice this in class tomorrow. I know it seems confusing at first, but once you get the hang of it, it's really not that bad. Okay? Have a good night.